The story of the Romanovs, the last imperial dynasty of Russia, is one of splendour, tragedy, and surprising scientific discovery. Beneath the glittering courts and political intrigue lies a lesser-known thread: the genetic origins of the family, and how modern science has helped unravel their fate. The Romanov dynasty began in 1613, when Michael I of Russia was elected Tsar after a period of chaos known as the Time of Troubles. Over the next 3 centuries, the Romanovs transformed Russia into one of Europe's great powers. Among the most famous rulers were Peter the Great, who modernized Russia and founded St. Petersburg, and Catherine the Great, whose reign marked a golden age of culture and expansion. By the early 20th century, however, the dynasty had grown increasingly disconnected from its people. The last Tsar, Nicholas II of Russia, ruled during a time of enormous social unrest. His reign saw the catastrophe of World War I and growing revolutionary movements at home. In 1917, the Russian Revolution forced Nicholas to abdicate. The Romanov family, Nicholas, his wife, Alexandra Fyodorovna, and their 5 children, were placed under house arrest. In July 1918, they were executed by Bolshevik forces in Yekaterinburg. For decades, rumours persisted that one of the daughters, particularly Anastasia Nikolaevna, had survived. One of the most fascinating aspects of the Romanovs lies in their genetic heritage. Like many European royal families, they were deeply interconnected through marriage. Alexandra, for example, was great-granddaughter of Queen Victoria. The connection brought with it a devastating inherited condition, haemophilia, a disorder that prevents blood from clotting properly. The Romanov heir, Alexei Nikolaevich, suffered from this disease. His illness not only affected the family personally, but also politically, as it contributed to the influence of the mystic Grigory Rasputin, who claimed he could ease Alexei's suffering. Genetically, haemophilia is carried on the X chromosome, which explains how it spread through royal lineages descended from Queen Victoria. Alexandria unknowingly passed the condition to her son, illustrating how dynastic marriages could amplify inherited risks. For much of the 20th century, the fate of the Romanovs remained uncertain. That changed in the 1990s, when a mass grave discovered near Yekaterinburg was analysed using modern DNA techniques. Scientists compared the remains with living relatives, including Prince Philip, Duke of Edinburgh, a descendant of Queen Victoria. Through mitochondrial DNA passed down the maternal line, they confirmed the identities of Nicholas, Alexandra, and several of their children. Later discoveries completed the puzzle, confirming all members of the family had indeed perished in 1918. The long-standing Anastasia legend was finally laid to rest by genetic evidence. The genetic analysis of the Romanovs, especially from the remains identified in the 1990s, revealed quite specific haplogroups for both the paternal and maternal lines of the family of Nicholas II of Russia. Victoria inherited this empty DNA from her mother, Princess Victoria of Saxe-Coburg-Saalfeld. The line was largely German aristocratic from the House of Saxe-Coburg, with roots in Central Europe. Although women do not carry Y DNA, Victoria's paternal lineage, through her father, came from House of Hanover. This dynasty was of German origin, ruling Britain since 1714. The Y DNA haplogroup of the House of Hanover is haplogroup R1b. The direct male line of Romanovs from Nicholas II belongs to haplogroup R1b. This is particularly interesting because R1b is most commonly associated with Western European populations, especially in regions like France, Britain, and parts of Germany. This reflects the fact that the Romanov ruling line was that of European aristocracy, especially German nobility. The dynasty was not genetically Slavic, like many might assume. For the maternal lineage of Alexandria Feodorovna, and thus her children, the haplogroup identified was haplogroup H1b. This lineage connects Alexandra directly to Queen Victoria, whose descendants carried the same mitochondrial DNA signature. These findings helped confirm the identities of the Romanov remains through comparison with living relatives, including Prince Philip, Duke of Edinburgh, who shared the same maternal lineage. It also illustrates a broader point. European royal families were genetically interconnected. Political marriages shaped not just alliances, but DNA. Traits and diseases like haemophilia spread across dynasties. The Romanovs' genetic profile shows how eagle monarchy is. Their DNA tells a story of centuries of alliances, migrations, and inherited legacies, woven across Europe rather than confined to one nation. Today, the Romanovs remain a symbol of Imperial Russia's grandeur and downfall. Their story has inspired countless books, films, and myths, blending fact into legend. Yet perhaps the most remarkable chapter is the one written not by historians, but by scientists. Through genetic analysis, the Romanovs, once shrouded in mystery, have been brought back into the light. Their identities confirmed, and their story grounded in both history and biology. The DNA evidence clearly shows the family had eagle Y DNA and serpent mitochondrial DNA. As with most modern-day royals, they were hybrids. Eagle males who wanted to get as much of the serpent DNA into their children as possible, so always had children with women strong in serpent genes.